Ashok? Ashok? Shashibhushan? Hello, Shashibhushan, respond. Accept it now.
Good evening, sir.
Good evening, sir.
Good evening, sir. Aurov sir, good evening. Narendra Babu sir, good
Good
evening.
evening.
Good evening, sir. Good evening, sir.
Ramesh Reddy sir, good evening. Coordinators Narendra Babu gariki good evening.
Good evening, sir. Good evening, sir.
Good evening. Aurov Babu garu good evening.
Good evening, sir. Ramesh Reddy garu.
Aurov Babu garu good evening. Good evening.
Background is run అవుతున్నట్టుంది. Good evening, sir. Ramesh Reddy, sir.
Good evening Ashok.
Questions. Weighted average of numbers given the scope of syllabus and subject.
Okay, sir. Aurav sir, shall we start?
Yeah, start చేద్దాం sir.
Okay. Good evening to all of you. Today is the fourth day. So in this regard, I mean, yesterday's session was very beautiful. You got full hands-on train program, and you got everything. I mean, whatever the simulation, how to send packets to different networks that you have utilized. So today, to start the session, I invite IC coordinator Dr. Professor Ramesh Reddy garu to address the gathering. Please, Ramesh Reddy sir.
Good afternoon sir. First thank you Aurov Babu garu for inviting me today. And thank you organizing team, coordinators Narendra Babu garu, Shashibhushan, and congratulations to P. Lakireddy garu for taking class daily. I think 1 hour it is scheduled from 4 to 5. And congratulations to all participants for your patient listening. Sitting 1 hour is also somewhat difficult continuously, and you are listening the things and gain the knowledge and apply wherever it is required. Most of the faculty, I think, most of the faculty are busy in this COVID duration by attending programs or by organizing programs, etc., etc. Here, one important thing is we are attending the programs, but we have to think what is the use of that program, whatever program you are attending. You have to think about that program, where it is useful, how it is useful, whether in the development of a curriculum or syllabus or preparing question papers or in research or your personal development. That is very, very important. Just attending the thing, getting the certificate and finally submitting to the college or department or filing. Okay, that is good during this COVID pandemic duration. We are doing good thing, but we have to think in that direction. After attending this program, whether computer network, suppose you are dealing computer network subject or some other subject related to this, just compare your previous lecture or notes, whatever, and present lecturing, what you are doing, what you are updating the things. That is very, very important. Second thing is, suppose if you are in autonomous system, we have a freedom to revise the syllabus, prepare course, complete syllabus. Okay, after attending this, just go through what are the previous contents, previous syllabus, and what are modifications required, what is the outdated things. We need to remove all outdated things, and we need to add these advanced things or more practical things. Okay, all of you keep in mind. Okay, that's all. Okay, sir. Thank you, sir. Thank you for inviting me, and congratulations, Lakireddy garu, because sir is doing wonderful job. Our teachers also telling all sessions are good. Okay, thank you, Garu, for inviting me. Thank you.
Thank you, sir. Thank you, Ramesh Reddy, sir.
Thank you, sir,
Thank
for
you, sir.
joining us.
Thank you.
Yeah. Yesterday it was static routing and how we can establish a static routing was clearly explained by our resource person Lakireddy garu. Today we can see the dynamic route and how to establish dynamic routing between the networks. So without wasting time, I invite Lakireddy garu to take over the session. Thank you.
Thank you, sir. Thank you very much. So, good evening, all of you. Good evening, respected HOD, sir, Professor Amar Babu, sir, and Ramesh Reddy, sir, and Narendra Babu, sir. Good evening, all of you. Sir, shall I start or? Sir, shall I start or any?
Sir, start, sir.
Sir,
Okay.
you can start, sir. Slowly the people will join, no problem. You can go ahead, sir.
Okay, okay. Okay, sir. Thank you, sir. Thank you very much. I welcome all the participants for the fourth day session. So I'll share my screen. Are you able to see my screen?
Yes, sir.
Yes. Okay,
Yes.
thank you. So the today's session will be dynamic routing using routing information protocol. Okay. So we have seen the static routing, the last class. So there, complete routing we have to specify user or administrators to specify complete routing manually. That's what we have seen, and we have configured every router with all the networks that are available and that we want to use in the network. So for all those networks, we have configured manually every network path. Okay, that is the network ID, net subnet mask, and through which which router it is going to be accessed. So these details we have configured for every network, And for certain networks which we may not be knowing, still we want to access them. So we have configured the routing called default route. A static default route also we have configured in every router to access the networks that are not known, because those networks, if we don't know their network addresses, we cannot configure them. In that case, the default route will help us accessing of those networks. So these are the things we have seen in the last class. Today, what we'll do is, instead of we configuring every network path, so we'll ask the uh, router to configure the all the network paths by its own. So for that, what
Okay.
we are going to do is, we may be enabling certain protocols. So that is,
Okay.
in our case, today's case,
One
that is
second.
routing information protocol. So I request all the participants to
হুম,
mute your mic.
এতক্ষণ পরে সময় পেয়েছি সারা সকালের পরে।
Narendra Babu sir, please mute all the participants' mic.
Yeah, I will mute all of them.
So today's contents: introduction, dynamic routing protocols.
Sir, sir, you unmute yourself.
Okay, sir. So today's topic is a small topic only, doesn't take much time. So topics are introduction, dynamic routing protocols, load balancing, and configuring routing information protocol. So these are the four topics we are going to cover for today. So the dynamic routing protocol, it can be implemented for any network if the network size is medium to large. Because for the small networks, static routing is the better one, and for the medium sized or large size network, so recommended is dynamic routing information. That is, configuring the dynamic routing is suggestible or recommendable for a network which is medium to large size. Because if the network is a medium to large, we may be having so many number of networks to be configured for their routes. That is a cumbersome task for the administrator or user. That is the reason we'll prefer dynamic routing task for medium to large networks. Am I audible? Is my voice is clear? Hello?
Sir, yes, sir. Clear,
Yes,
clear.
sir. Yes, sir.
Okay, sir. Okay, sir. Thank you. Thank you. So these are when we can go for the dynamic routing, the three different cases are there where we are going to prefer the dynamic routing. First is if networks have more than few routers. If considerable number of routers are there, then dynamic routing is preferred because more number of network paths will be available. So configuring all these more number of network paths is a time taking process. That is the reason we'll prefer the dynamic routing. The second, whenever there is a change in the network, suppose due to some reasons, if a particular router in the entire networks go down or something goes wrong with a particular router, then the routing through that router cannot be taking place. Then, so this may not be known to the administrator to reconfigure that, but if we are enabling the dynamic routing protocols, the protocol will detect the down state of the router. Immediately, it will find the alternate paths, and those alternate paths will be included in the routing table. This is being done by the router itself if we configure the dynamic routing protocols. Whereas if you are using the static routing, if a router fails in a particular place, then through that router no routing is going to taking place. So whatever packets are being sent through that router will be dropped somewhere. As a result, the communication will not reach the destination and the source will not get any reply for that. So if the administrator knows about the down state of a particular router, then he can manually configure some other paths. But there is no guarantee that the administrator will be knowing the down state of a router the moment it goes down. So need not be. He may not be knowing about it. So this is a disadvantage by using the static routing and advantage of dynamic routing. Okay, as and when there is a change in the network configuration, dynamic routing protocol will take care of alternate paths for the destination, and that path will be included in the routing table. Even if a particular router is removed, and the dynamic routing protocol will take care of that, and it updates the routing tables, okay, from time to time. That is the second thing. Third, scalability means if you want to upgrade the network or you want to resize network by removing some systems or some routers in the network, or if you want to add some more things, so the dynamic routing protocol immediately will detect the changes in the networks. Accordingly, the dynamic protocol will automatically detect the new routes, new paths, and those paths will be included in the routing table. So these are the cases where we go for dynamic routing. Okay, and if you compare the static routing and dynamic routing, so in this particular table, the first configuration complexity. So in case of dynamic routing, independent of network size, because the administrator need not do much. Okay, as a result, so routing information protocol will take care of building the routing tables. So as a result, so independent of the network size, we can use the dynamic routing protocols for creating the routing tables. Whereas static, if network size increases, the administrator task increases. Okay, in case of static route, because if the number of networks increases, the number of static routing table creations increases. As a result, the task of administrator increases. That is the first point. The second point, topology changes. If the structure of the network is being reorganized or changed, then dynamic routing protocols automatically find detects the same, and accordingly it adjusts its network according to the changes, and new tables will be created. Whereas in case of static routing, the administrator has to know the changes, and he has to make those changes accordingly by himself or herself by configuring manually. That is topology changes. Scalability, suitable for simple to complex networks. Dynamic case, so any size. If you increase some medium to large size, also no problem. So dynamic routing protocol will take care of that. Whereas for simple networks only, small networks only, static routing is preferred where the number of routing paths are minimum. Security purpose, in case of dynamic security purpose, it is less secure, because separate security arrangements to be made, because in the dynamic routing protocol so many paths are being detected, so many paths are being included in the routing tables, which may be vulnerable for the security. That is one reason where in the static routing the routing is configured by the administrator by manually. As a result, those paths are more secure. That is security part. So static routing is having advantage compared to dynamic routing. Resources usage. So resources usage, as and when there is a change in the routing tables or routing information, accordingly the usage of CPU, memory, and bandwidth. Because if network size increases, some more paths will be added. Those paths will take some space in the memory for entering in the new routing paths. So that takes some space, and that utilizes for gathering the routing information from neighboring routers. For gathering, it has to use the bandwidth. So for all these things, CPU has to involve processing of these things and creating the routing tables in case of dynamic routing. Whereas in case of static, once the administrator create the routing tables, those tables are permanent. So in between, those tables need not be changed unless otherwise there is a scalability. Accordingly, administrator has to configure. Otherwise, as and when, as long as there is no change in the network size and no change in the resources, then once configured static routes are permanent. So whatever amount of space it is using at the time of creation of the routing tables, that is standard, that is permanent. So no more space is needed for that, no additional bandwidth because already table is created. So no need to create any additional tables. That is why no nothing to be received from adjacent routers about the routing information. As a result, no additional bandwidth is needed. So that is for resource usage part. Only for creating the routing tables, not for the exchanging the information. Then path predictability. Case of path predictability, route depends on topology and routing protocols used. So in case of dynamic routing, depending on the routing protocol, again we have number of dynamic routing protocols are there. So out of them, we'll be discussing about RIP and OSPF. Today RIP and tomorrow OSPF. So the depending on these protocols, automatically they will detect the new paths. Okay, new paths, and accordingly the entries will be made in the routing table. Whereas static routing explicitly defined by the administrator. The complete route is to be defined or created by the administrator on his own. Okay, so that is these are the comparisons. Based on these parameters, we can say dynamic routing is preferred over static routing for a medium size to large size networks because the administrator involvement is minimum. Okay, the administrator's involvement is minimum in this. As a result, so dynamic protocol is preferred in configuring the routing. Okay, so suppose if this is the network, a particular network we have, and this a router R1 and router R2. So what they does is initially how they will exchange the information is, say if router R1 comes into on state and router R2 comes into R state on state, then router 1 will say to router 2. Router 1 will pass information to router 2 that it will say that I know this network, I know this network. Okay, that information R1 will pass to R2. Then R2 will receive that information. It is being stored in its database, and again R2 will send back to R1 that it will say, I know this network, I know this network, I know this network, likewise. So this information R1 will receive. So and it is going to use that as a database. Based on this database, R1 will create its own routing tables from with the help of dynamic routing protocols. Similarly, R2, whatever database it is receiving from its neighbor routers, it is going to create the database. Okay, so that is what is being happening in case of dynamic routing protocols. Okay, so immediately the moment they are come to on, they will exchange this information. Even as and when there is any change, suppose if there is any change on this side of the network, then immediately those changes router will detect. That is dynamic routing protocols of this router will detect the changes in this particular route or that network. Those changes will be incorporated in its table, and the same thing may be informed to R2 also. Okay, similarly if there is any changes in this, that will be informed to R2. Similarly R2 will inform if there is any changes in this network or this network or this network, those changes will be intimated to R1. Accordingly, all these routers will update their routing information by gathering the information from neighboring routers. This is what is happening in the dynamic routing protocols. Okay, so for this what it does is, so they are going to, so some of these tasks, okay, these routing protocols, they will gather the information from neighboring routers and they will use that as a database. From the database they will create the routing tables. Okay, so for that what the steps are: discovery of remote networks. So how they discover means, so from the neighboring routers they will listen about the networks that known. Okay, so all this information gathered from different routers will be stored as a database. So from the database, it is being stored as a database. From the database, a routing tables will be created. So from the table, it knows the best path. Okay, from the table, it is going to identify the best path for a particular destination, and it will use that best path for delivering the information from source to the destination. Okay, suppose if that best path is not available due to some reason, then the dynamic routing protocol will find another path to that. If what are the other paths available, out of those other paths available to the destination, it will find the next best path, and that next best path will be used for delivering the information to the destination. Okay, so this is what automatically the dynamic routing protocols does. Okay, so how it is being creating the routing table in the steps are data structure, database. The database is nothing but gathering the information from all neighboring information, all neighboring routers. Okay, so suppose a network, for example, in our case, say router 0 is having connected with three different networks. Okay, in our case, router 0, in last example, previous example, router 0 is connected with three different networks. So it is going to inform about those three networks to router 1. Then router 1 will gather the information about what are the networks connected to it and whatever information it is receiving from router 0. So, and together it is going to create its own database. Then that database it is going to forward to say router 2. Okay. Similarly, so router 1 will gather the information from router 2. Then that is being forwarded to router 0. So as and when there is any changes, they will exchange this information between them. So that entire is being uh, called as database. That database every router will use for creating the routing tables. Okay, so routing protocols is various types of messages. Different messages will be used depending on the protocol. So different messages will be used for creating the routing tables. For example, RIP, a router will say network 1 is connected to me. It is directly connected to me, for example. That it will say to the next router. Okay, then router 1 will gather this information, and suppose network B is directly connected to router 1, then router 1 will pass to router 2 that network B is directly connected to me and network A is one hop away from me. That means one more router is there to reach network A. The meaning of that is, so if a particular router is announcing that was a particular network is say 2 hops away from me, means between that network and me there are two routers in between. That is the meaning. Likewise, so RIP will inform two adjacent routers about all the information that it has gathered. Okay, so that is the second thing. Third, the algorithm. By using once the database is being gathered, then the RIP will apply the Dijkstra's algorithm. In this particular case, RIP will use the Dijkstra's algorithm to find the shortest path for a destination. So from the database, it will see so what are the routes or what are the paths available to a particular destination. Once a path is available to a particular destination, then the Dijkstra's algorithm is applied on that. Okay, to find the shortest path for that particular destination from multiple paths. Okay, so for every destination, so there may be available multiple paths. Okay, because every router is passing this information. Okay, so for the same destination, so from the routers it may gather different paths for particular destination. Then out of these different paths, which path is to be used? The best path is to be used. How the best path will be decided? So on that database, it will apply the Dijkstra's algorithm. Okay, by applying the Dijkstra's algorithm, it will detect, it will find the shortest path, and that path it is going to include in its routing table for communicating with the destination every time and any time. Okay, like this entire database. So for destination wise, it is going to separate entire database. On destination wise, it will apply the algorithm and it will decide the best path. Then the best path is included in the routing table. Okay. The best path is selected by routing protocol based on value or metric. So RIP will use the metric as hop count. Okay. So the distance is measured in terms of hop count in case of routing information protocol. Means to reach the destination, how many routers it has to cross. Okay, that is the meaning of hop count. Right? If hop count is 2 means it has to cross 2 more routers to reach the destination. Okay, so even we can see this part once after configuring, then we'll see this by giving the command show IP route. Once we give the command show IP route, then a routing table will be displayed. From the routing table, we can identify what is the hop count to reach that for that particular destination. Okay, so this point we'll see practically. So after configuring the RIP. Okay, so for example, we'll be using RIP and OSPF. So for RIP, the metric is hop count. Okay, your hop means a router, right? Hop number of routers present between the source and destination. So each router along the path adds up to hop count. Okay, so the moment it crosses one hop count will be decremented. The moment hop count is 0 means it has almost reached the destination. So generally, by using the RIP, the maximum hop count allowed is 15 hops. Maximum 15 routers can be there in between. That is a limitation for RIP protocol. So that is why nowadays, so RIP is less preferred compared to OSPF. Okay, and the OSPF, the metric is cost. The metric is cost. So cost in the sense, suppose whatever bandwidth we are using, line bandwidth, that is called reference bandwidth, divided by your network interface speed. Okay, line speed divided by your network speed. So your network interface card speed. That is the cost. Okay, that is the cost, and the cost is cumulative. Suppose you have, say, between router 0 to router 1, whatever line you are connecting, the reference bandwidth or the bandwidth of that line divided by your network interface card speed, that gives the cost between router 0 and router 1. And again, router 1 and router 2, the link speed or bandwidth of the link and NIC interface speed. So divide by that cost means, so between router 1 and 0 and 1, so you have a cost plus the cost of between router 1 and 2. Likewise is a cumulative cost between the source and destination that is being used as, so in OSPF. Okay, so to measure the distance or to measure the metric, this is the cost is the measurement for the metric. So faster links are assigned lower cost. Faster link, suppose the line speed is 10 Gbps and I am using 1 Gbps network interface card, then 10 Gbps by 1 Gbps, cost is 10. Okay, cost is 10, right? And suppose I am using the line speed is 10 Gbps, but my network interface card is 100 Mbps. 1 Gbps by 100 Mbps, that gives me cost 100. Okay, so lower speed link, lower speed network interface will give more cost. Higher network interface card will give less cost. So the preferred one is less cost. Okay, that is how we'll be using cost factor in case of OSPF. Right, and one more thing is load balancing. So this point we have not come across in case of static route. But in the dynamic route, this is one more feature available, load balancing. That is, suppose, so from a source to the destination, suppose A is a source, B is a destination. Between A and B, if two paths are available, which are having same hub count, cost is same, or metric is same. Okay, then both paths will be available in the routing table. If at all they are available with the same cost, so same cost means both are preferred path, both are best paths only. So both the entries will be there in the routing table. Suppose one is having cost 4, other is having cost 5, then whatever path is having cost 4 is the best path. Okay, that means it is having only 4 routers between. So the message has to cross these 4 routers only. Whereas cost 5 means, so hub count 5 means, so 5 routers it has to cross. That will take more time. As a result, that is not preferred. Okay, but there are possibility sometimes two paths available with the same metric or same hub count. Then, if two paths available with the same hub count, both are best paths. Both are called best paths because equal cost, equal metric, equal time it takes. As a result, both will be treated as the best paths. Then, so the information, if at all, from A to B it has to pass. So part of the information through one path, part of the information through other path. That is because whatever information is being exchanged between A and B, it is being exchanged in terms of packets. Okay, so as a result, few packets through one path, few packets through other path will be transmitted, so which will improve the performance of the network because traffic is being shared between these two paths. Traffic is being shared between these two paths, so that is why it is an advantageous in the network, so which improves the performance of the network. Okay, so that is what is called load balancing, right? So whatever amount of data or whatever number of packets are to be transmitted, if at all two paths with the same cost is available, the load is being distributed between these two paths to improve the performance. That is the meaning of load balancing. If configured correctly, load balancing can increase effectiveness or performance. Okay, equal cost load balancing is implemented automatically by dynamic routing protocols. That is, so if two paths available, if the same cost, not only two paths, even if three paths are available at the same cost, all the three are best paths. Okay, all the three will be included in the routing table. If four paths are available with the same cost, then all four will be included in the routing table. Okay, so even if n number of paths available with the same cost, okay, which is minimum, then all those n paths will be included in the routing table, and the communication between the source and destination using all these n paths will be used for load balancing. Okay, so this is a dynamic routing protocol feature. Even OSPF does the same. Okay, all the time, because this we have not used because we have configured only one path per destination in case of static routing. So there is no question of alternate path with the same cost. Okay, alternate path with the same cost is not there. So as a result, so we are not using load balancing concept in case of static routing or static routing. Okay, so that is about the load balancing. The next is, so configuring. For configuring, we'll be giving the commands like this. Okay, from, so user mode, enable, you will go to the privileged mode, then config T, global configuration mode, then you are going to give the command like router RIP, then version, then the network address is connected to that particular router. This is how we are going to give the configuration. Now we'll go to the practical part. So am I clear up to now? Are you able to see my packet tracer screen? All of you?
No, sir.
No?
Yes,
Now?
sir.
Are you able to see this? Okay. So same
Yes, yes.
same structure we are using, whatever we have used in the last class, same structure we will be using. So here what I will do is, already in this particular structure IP address is configured. Okay, I'm not going to configure the IP address again, because already this we have discussed in the last class, right? Only routing part we'll see. For that, if you see, enable, okay, show run. So I'm displaying the running configuration present in this particular router. To see this, what is available about the routing tables, nothing is there. Okay. About the routing table, nothing is there. So what is there? IP addresses are being configured. Okay. So three networks are connected. So three IP addresses are configured. So G 0/0. So 192.168.1.1, that is this network. Okay. And G0/1 192.168.2.1, that is this network. And serial 0/0/0 192.168.3.1, that is this network. Okay, so only these three direct connections we have added. So only the IP address we have configured. We have not at all configured the routing part in this. Okay, so only direct connections we have made with this. That is, if you want to verify, see, let us send the packet from
Sir,
PC0,
sir,
sorry, PC4,
little bit
right?
voice problem is this. Please correct it.
Avuna? Is it
Light,
okay now?
light. Yeah, yeah. Okay, okay, good.
Okay, okay,
Yeah,
sir.
yeah.
Okay, sir. Thank you. Okay, so now what I did, I have sent a packet from PC0 to PC4, but it's failed. Okay, maybe first time it is failed. I'll let me check again. Again, I am sending packet from same PC0 to PC4. Again, failed. Why this is? Because the routing is not configured between the routers. Okay, so we have to configure the routing between these routers, then the packets will be moving freely without any problem. Okay, in previous what we did, whatever we are going to configure in this static, what we did, we have added this network, its network, and subnet mask, and this address we have added in the IP root command. Okay, about this network, the network ID, then subnet mask, and this interface we have added. And about this network ID, subnet mask, and this interface we have added. If you remember, recollect whatever configuration we have made yesterday for the static configuration. And for this network ID, subnet mask, and this interface, because through this only I can access this. Okay, so about this network ID, subnet mask, and this interface. Okay, likewise we have added in this router the static routing configuration. For this router, what we did, these four are directly connected. Then for this network ID, this subnet mask, and this interface. This network ID, this subnet mask, and this interface I have added on this. Again about this network ID, this subnet mask, and this interface I have added. Okay, about this network ID, subnet mask, and this interface I have added in the IP root command for this router. Okay, and for this router, these are directly connected. Of course, this is also directly connected. So these are directly connected. And for this, I have added this network, subnet mask, and this interface. For this network ID, subnet mask, and this interface. For this network ID, subnet mask, this interface. This network, subnet mask, this interface. For this network, subnet mask, this interface. So this is how we have added in the routing table manually in static case. Now we are not going to add. So for this, we are not going to add all these networks. I'm going to enable these networks using the RIP, okay, in this router, okay, in this router. Then in this router, I'm going to enable the RIP with these four networks only, okay, with these four only. And in this router, I'm going to enable RIP with these three. I'm not going to enable this, okay. Let us use again default route for this, like we have used the default route for these two networks in the last class. Same way, here also we will use the default route for this particular part of the network, okay. Only these 8 networks let us use for dynamic configuration, and these two networks let us use as a default route, okay. Similar to the last class, right? So in this router I'm going to configure with these three networks only using RIP. Then the RIP, let RIP gather about this, let RIP of this router gather about this. Similarly, let RIP of this router gather about these two networks and these networks. Let the RIP of this router gather about these networks, okay, that we will see. So simple example, before going to that, if I say show IP route, I give the command, what is being displayed in this? The moment I give the IP route command, what is being displayed? 192.168.1.0, okay. So that is this network. This network is directly connected to the router. That is why you C means directly connected network. Okay, it is a directly connected network. Then 192.168.1.1, that is local. So for this router, so this interface is having the network ID 192.168.1.1. That is local to this. The network is that this network is directly connected to this, and this is interface is local. Okay. Similarly, this network, that is 192.168.2.0, this network is directly connected to this, and 192.168.2.1 is local to this interface. Similarly, this. Okay. So wherever you are seeing C is direct connected network, L means local interface. Directly connected network and local interface. Directly connected network, local interface. Okay. So 3.1 is the local interface. This is the directly connected network. So everywhere, because we have configured these three IP addresses in this, so we are able to see this, right? Now what we will do is, now we will configure the RIP. So for that, what you do is give the global configuration command config dot t, sorry, space t. Okay. Now we are in global configuration mode. So in global configuration mode, now let us give the commands for configuring these networks. Okay. So what I will do, router RIP. Okay. My first command is router RIP, right? The latest version of RIP is version 2. So I will give version 2. Okay. So next, what is the network connected to this? 192.168.1.0. So my next command is network 192.168.1.0. No need to give the subnet mask. Simply network ID. Okay. So what else network is connected to this? 2.0. Okay. This is 192.168.2.0, my second network. My third network is this 192.168.3.0. So I'll give 3.0. Okay. So these three networks connected. So whereas in the static routing, what we did? We have configured for this router all other networks. Now we are not going to do that. Okay. Let RIP gather about all other networks. Okay. So now what this router does, it is going to indicate that these are the three networks connected with me. So if anybody wants, they can reach these networks through me. That is the information it is going to pass. Okay. So now my RIP configuration in router 0 is over. Okay. Next, and right. Next, I will save this configuration, right. Okay. So my RIP configuration in router 0 is over. So these three networks, they are directly connected. Only those three network IDs will specify network. So yesterday in static case, what we command we have used? IP root, the network ID, subnet mask, and via. Now we are not using any of those things. Okay, that is the difference, right? Clear? So now I move to my next router. Okay, so enable, right? If you want, you can see show IP root. Okay, if you see, so four networks are connected to this directly, right? 172.16.1.0, 172.16.2.0, 172.16.3.0, then 192.168.3.0. Four networks are connected to this. So those four networks only are going to see directly connected: 172.16.1, 172.16.2, 172.16.3, and 192.168.3.0. These are the four networks directly connected and four interfaces local. Okay, so that is what only we are seeing. Now we'll config T. Okay, global configuration mode. Now what is my first command? Router RIP. Next, version 2. Okay, next, network. What are the networks we have? 192.168.3.0. Okay, that is this network, right? Next, we'll configure these three networks. So next, 172.16.1.0, that is this network. Okay. Next, 172.16.2.0, this network. One 172.16.3.0, this network. Okay. So four networks I have configured. Next, and right, then right. Next is right. So now this is being over. Next, I'll go to the third. Enable show IP root. So here also what four interfaces are there? Four networks are there connected to this. These are the four. Okay. Connected 10.10.1.0, this network. 10.10.2.0, this network. Okay. 172.16.3.0, this network. 200.200.200.0, this network. Right. This is about directly connected. Right. Now let us config st. Okay. So what is my first command? Router RIP. Next, version 2. Version 2. Okay. Next, network network 172.16.3.0. Okay, next network 10.10.10.1. Next 10.10.2. Next. Okay, only these three letters, because we want to use the 200.200.200. We will let us use for the default configuration. So I'm not going to configure that. Okay, I'm not going to configure about it now, right? But what I will do is I'll use one command here for default hyphen information, default information originate. Okay, default information originate, right? Then, so in this particular route, in this particular router, what I'll do is I'll configure, so default route. Okay, I'll configure the default route. What is the default route? Is this. Okay, so IP route 0.0.0.0 space 0.0.0.0, then 200 dot 200 dot 200 dot 2, that is this interface. Okay, right? This is what we have used, right? Now our configuration is over. And okay, then save, right? Okay, this is what we have seen. Now we have configured default route only in R2. In R1, R0, we have not configured the default route because dynamic routing protocol take care about. Whereas in the static case, we have configured the default route in every router. Okay, so in this, what we'll do is, case of ISP, enable. Okay, then show IP route. What is there in this? Only two interfaces about this and this. Okay, what we'll do is config T, right? Now we'll give the, see, if we are not configuring this, what will happen in this? From any of this network, information will come to this, but no reply will go back because this router ISP doesn't know about any networks. Okay, no routing we have configured in ISP, so default route only will configure, right? So that is route IP route 0.0.0.0 space 0.0.0.0 space 200.200.200.1, that is this interface. Okay, now it is over. And right, and save WRAT, right? Okay, now we have configured all the routes. Suppose now I come to this. Okay, if I say show IP route, if I give the command show IP route, if you see now, so what is being displayed? See, your default route has come here. R star, star indicates the default route, but we have not given any default route command in this. Okay, we have not given any routing command, right? Next, if you see 10.0.0.0/8, so all the networks of starting with the 10. So RIP has gathered, but we have not specified anything about 10.10 network, in R0, but it has been gathered by RIP. Okay, 172.16.0. About that network, we have not given any commands in this, but RIP has gathered that routing information. Okay, so it has gathered all other routes available, though we have not given the commands for other networks. Simply we have enabled our three networks with RIP. Okay, in this router, what we did, these three networks we have enabled with RIP. So then RIP did the rest of the things for us, gathering all the routes. Okay, so this is how it has gathered already, right? Next, let us see. Let us see. If you see here, what is being given? If you see here, 10.10.0, this network 120 administrative distance. So already yesterday we talked about administrative distance. Default as administrative distance is 120 for RIP, 110 for OSPF, okay, and one for static, one for the static, okay, right? So if you see this 10.10 network, how many routers it has to cross? See, to reach this network from here, it has to cross two routers. Okay, these two routers it has to cross to reach this network, right? And to reach this network, it has to cross these two routers. Okay, whereas to reach this network, it has to cross only one router. To reach this network, it has to cross only one router. Remember, so if 172 network is to be reached, only one router to be crossed. If 10 dot network to be reached, we have to cross two routers. If we see this 10 dot network, so 120/2, this is your hop count. Okay, this is the hop count. So you need to cross two routers to reach a network of 10.10. And so on 70.16 network, only one router you have to cross. Okay, we need to cross only one router to reach this 172.16 network. Okay, so that is how. So it will display. If you give the command show IP route, it is going to display the routing table. This is the routing table. This is routing table, and these letters indicates which protocol has gathered this. So local, directly connected. This is, we have given direct configuration of IP address. This R indicates RIP protocol has gathered about these routers. So RIP protocol has gathered this default route. Okay, it has gathered this default route. Okay, this is how it is. So if you see from this, right, show IP route. If you give the command show IP route, if you see this, so 10.10 network, only one hop. Okay, so from this, only one router it has to cross to reach this. Okay, from this 192.168.1, only one hop. It has to cross only one router. So that is how the up count. So 10.10.10. So 192 network. Again, default route. We have not configured the default route even in R1, but it has gathered by RIP. Okay, right? That is about configuration of RIP. Right? Now, let us see whether communication is happening or not. Okay, let us try out a packet from this to PC4. First time it is failed. 1 to PC4, successful. Okay, this PC0 to say PC8 in progress. First time attempt is failed. Again, we'll send the packet PC0 to PC8. Now it is successful. Okay, Similarly, I'll send a packet from PC0 to server is failed in first attempt. I'll send again PC0 to server successful. So from PC1 to server successful. From PC2 to server successful. From PC3 to server successful. Okay, but we have not configured about this network in any of these routers. Only we have given the default route. Because of the default route, we are able to access the server. Suppose we want, say, from PC6, desktop, web browser, okay? And if you type the address of server 8.8.8.2 and enter, so you are able to access the server. Okay, what is there in the server? We can see. Okay, right? So whatever you have information in the server, you can access. That is how the dynamic routing information or RIP, setting of RIP, right? So that is for the day. Today is a small topic only. If you have any queries, if you have any queries,
Yes, sir.
Any queries, please ask by unmuting your mic.
Yeah. Hello, sir. Sir, I
Ah.
have a doubt, sir. Sir,
Yeah.
why is it first time we are not able to have a successful transaction? I mean, whenever
Because it is not detecting first time. It is not
that's
detecting
what
the
my
path
question is, sir. And
properly.
I
Yeah.
mean, in the real time and all, we cannot, leave the first time chance, right, sir? I mean, how can we
It's
overcome
only
that?
simulation. So simulation it is taking time. So for
Okay.
settling off itself, that is reason first attempt we were getting that is failed. That is only
Okay.
sometimes, not always.
Okay, sir. Sir,
Okay.
one more doubt, sir. So, for
Yes.
example, we are trying to ping some server. Server is a physical location, sir, right, sir? Somewhere it will be sitting. I mean,
Server is somewhere a device. It is also a system.
yeah, it is also some database kind of thing. Somewhere
Yes,
it
it
will
will
be,
be having.
sit. For
Ah,
example, from my laptop, I want
ah,
to, access some Google server, for example,
ah,
right? So
ah.
it will be sitting somewhere in some country. Even
Yeah,
we
it
are
may
not
be
aware of.
anywhere. Okay.
Yeah, so you were telling how many routers it has to cross, sir. For example, I am trying to ping my from my computer to
Ah,
Google.
ah.
How many routers it has to cross? Like, you were telling somewhere 15 routers is the
50, that is
maximum.
if you if we are configured our network using the RIP protocol, so it is about 15 routers maximum. Whereas OSPF there is no limitation,
I
and we are
no, sir. My question is,
uh,
what is the process? How I am able to ping? What is the process? For example, I am using some broadband connection now to
uh,
access,
okay,
internet. I am
okay,
sitting on my laptop now.
uh,
So immediate next device it needs to cross is my laptop to my Wi-Fi router,
okay,
then to some ISP service
uh,
provider,
okay,
right? How will I, how would ISP connects to Google? So many ISPs will be there. What is the
yeah,
path? How can we? I
yeah,
hope you got my question. How?
yeah, yeah. If the network operating supports, you can give one command called as trace route. Okay, trace route command with the address of that server which you want to know how many routers it is having. Okay, so if you know the IP address of the server, then you can give the command trace route from the command prompt. From the command prompt, I'll show you that. uh, I'll go to the, so say PC0 desktop, then command prompt. I'll give the command trace 8.8.8.2. Okay, so if you see this, 1, 2, 3, 4 routers it is crossing.
Okay, we can do the same thing from our laptop
Yeah.
now, sir.
Yes.
We can know the IPs of the popular
No, that
servers
you
like
have to
Google.
find out through some other way,
Okay, sir.
because you have to know, because here we have configured this router IP address, so we
Yes,
are
sir.
knowing.
Yeah.
Okay, that is why I
Yeah.
could able to use that address.
Yeah, that's what my question is, sir. Here we are building our environment. We know
Yeah.
everything here. In the real time, how to understand, or how. Moreover,
That is
sir,
DNS.
within a fraction of
DNS.
seconds, we are getting reply from the server, no, sir.
Yes. DNS, domain name
Oh,
system, is the protocol we are
okay.
using. That will
Okay.
give you the IP address for the name. If you know the name of the server using the DNS, it will provide you the IP address.
That is what, sir. DNS
Yeah.
is name of it. Google.com is DNS.
Yes.
Okay.
Okay.
Okay, sir. Okay, sir. Okay.
Right.
Thank you.
So by using this command, now you will be knowing. So it is crossing 4 routers. 1, 2, 3, 4. Okay, sir.
Okay, sir. Okay, sir.
1.1,
Thank you.
that is this interface. 3.2, that is this interface. Again, 116.3.2, that is this interface. And 200.2 is this interface. Okay, sir.
Okay, sir. Thanks.
Are you clear now? Okay, sir.
Yes,
Thank
sir.
you.
I am. Thank you.
Sir, one more doubt is, suppose the server is some other network, so then how to trace server address?
Address, that is, we have to tracing in this. Unless you know the IP address, we cannot trace that. Only thing is you have to use the name. That name only you are browsing from the browser only you can give. But when you are using the ping command, or traceroute command, you need to use the IP address of the destination. Somehow you have to know that destination address.
Okay. Any questions? Please ask by unmuting yourself. Anybody? Okay, if there is no questions, before to end, there are informations we would like to share. So we'll share whatever the feedback link in Microsoft as well as in group also, and it will be active for 1 hour 15 minutes. After 1 hour 15 minutes, automatically it will be closed. So before that, you try to fill it, and do not ask for again and again for activate the link. So this is all information for all the participants. Kindly cooperate with us. Now, in a moment, we are going to share the feedback link. So the time is 1 hour 15 minutes. You please fill it, and so that we can have the attendance through whatever the feedback link. So
నరేంద్ర బాబు
that's all. Yeah.
సార్ 5:15కి ఎనేబుల్ అవుతుంది సార్, 6:30 క్లోజ్ అవుతుంది సార్ లింక్.
Yeah, the link will be activated around 5:15 and it will be around up to 6:30.
Yes, sir.
Yeah, very good. So before 6:30, try to fill it, and there is no extension again and again. Please cooperate with us. Thank you for the attending today's session, and tomorrow is the final session. So please attend early by tomorrow. That means 10 minutes before the session. Because we have again valedictory also there tomorrow. So please kindly come and log in as early as possible. That means 10 minutes before the scheduled time, 4 p.m. So that's all from now, and we will end this session right now. Thank you, Lakireddy sir, for wonderful session.
Narendra Babu sir.
Yeah.
Shall I close the meeting, sir?
Wait, already you have shared this feedback. Let them take.
It will be reflected, sir. It will be reflected there.
Okay, then you close. No problem.
Okay, sir. I am closing the meeting.